We did an inspection at the throttle body and we noticed there was a lot of oil residue. So we decided to dig a little deeper and break out the bore scope and start looking for carbon buildup in the intake manifold runners and behind the intake valves. As you can see here, we can definitely see the results of the carbon buildup on the back of the intake valves. Now this seems to be a big controversy in our industry on how would you repair this. If the vehicle is under warranty, and this is a little hard to swallow, but at the Ford dealer, they might choose to replace the entire cylinder head. Obviously, the rumor mill is that in some testing of using chemicals to clean the carbon off the valves, which technicians we've done for years, there was some carbon that got dislodged from the combustion chamber or behind the valve and made its way in and damaged the turbocharger. So they feel that by chemically cleaning, there is a risk, one, from carbon being broken off and damaging the turbo, two, that during the cleaning process there are elevated temperatures. But I want to remind you what we looked at earlier, that the alloy of the turbine is over Rockwell 60 tested. It's a super alloy that's being used. So we're at a point here, do we want to make a choice? Do we want to risk possibly damaging the turbocharger, or what are some options that may be out there? So let's look at what our options are that is going on in the industry. One is a chemically cleaning. We have to concern ourselves that we're not going to do any damage to the turbocharger. In the early 80s, there was a machine developed called a crushed walnut shell machine, in which you would remove the intake, possibly rocker arms or cam, close the valves, and shoot crushed walnut shells that would kind of bead blast the back of the valves, and then you would vacuum them out. If there was any little pieces of walnut shells left, they would just burn up in the combustion process and not have any detrimental damage to the engine. There's not very many shops that still have these crushed walnut machines laying around, so that option is pretty tough. Cylinder head replacement, that's rather expensive. Now, I would like to add something here, that only one manufacturer has decided to fix this problem with. This year, BMW does have an M engine that has water injection. You can imagine whenever the engine is under a certain amount of load, if we would interject some water or water methanol injection, it would keep everything super clean. As a technician, I'm sure we've pulled the head on an engine with a blown head gasket, and we know exactly what cylinder the coolant has been going into, because that cylinder, spark plug, valves will be whistle clean. I believe that water methanol injection is probably the future of some of these direct injected turbocharged engines that every manufacturer is utilizing. Only BMW at this time has chosen to use water injection as a viable way of keeping the back of the valves in the combustion chamber clean. You see, we don't have an injector shooting fuel to the back of the intake valve. In direct injection, it's shooting it directly into the chamber. The other option that is used by the BRZ engine, some Lexuses, known as the D4S system, is it has gasoline direct injection and port fuel injection. So you still have a port fuel injector that's spraying fuel directly to the back of the intake valve, keeping it clean. Some technicians are using water injection in the field. They've made their own apparatus. They go out and drive the vehicle rather aggressively, letting water injection in to help dissolve and clean the carbon, and some of those guys are getting some good results from those. We've elected, after talking with the customer and explaining to them the features and benefits of the CRC, we're going to go ahead and do the CRC cleaning on this 2015 Mustang. One of the cleaning systems that I've used in the past and have some experience with, and maybe some technicians out there also, is a motor vac cleaning machine. What was the gauge on the motor vac cleaning machine? You guys that have used one know that it was a vacuum gauge. What did Snap-on want you to do? They want you to look at the vacuum before the cleaning and after the cleaning. Well, this 2015 EcoBoost engine has its own built-in boost pressure, vacuum, and even air-fuel ratio gauge built right into the instrument cluster. So we're going to take a look after the cleaning at engine vacuum, what it was at idle before and after, just like we used to do with the older motor vac type Snap-on cleaning machine. Then we're going to keep the vehicle overnight and make sure that we've got rid of the customer complaint, the hesitation, and cold engine misfires. The directions on the CRC IVD cleaner tell you to administer the cleaning spray behind the mass airflow sensor. Obviously, we don't want the cleaner hitting the hot wires or the hot film in a mass airflow sensor. But wait a minute, this 2015 Mustang is EcoBoost. It does not have a mass airflow sensor. So what we're going to do is directly shoot the cleaner into the throttle body itself, because we can remove the snorkel from the throttle body and the engine will run normal, and we can introduce the cleaner making its way past the throttle body, through the intake valves, combustion process, cleaning the combustion chamber, the back of the valves, the spark plugs, the oxygen sensor, and even possibly cleaning the monolithic brick of the catalytic converter, and do a good cleanup job of all of this. Okay, we have completed the CRC IVD cleaning process on the Mustang EcoBoost. Now, I told you I was going to do a test. Let's look at those results. I've got a shot of engine vacuum and RPM before the cleaning. As you can see here, the boost vacuum gauge in the center of the dash is about 18 inches of vacuum, and the RPM is idling somewhere just under 1,000 RPM. So pay particularly close attention that the engine vacuum is 18 inches and just under 1,000 RPM. This is before the cleaning. Now, after the cleaning, pretty much the same engine temperature. Notice the tachometer is in the same exact position, hot engine base idle, below 1,000 RPM, but look at our engine vacuum now. We're just a hair over 20 inches of vacuum. So we picked up a solid 2 inches of vacuum after the upper induction cleaning. So there you can see the 18 inches, and after the cleaning, just a hair over 20 inches of vacuum, showing you that you have improved the induction system and the flow of air to the engine by doing a cleaning of the upper intake, the combustion chamber, spark plugs, oxygen sensor, the back of the valves, and possibly even the catalytic converter. So our second case study, the Mustang EcoBoost, was a success. We've improved the idle, throttle response, no more misfires when the engine's cold. So the CRC IVD cleaner was a success. We have no apparent any damage to the turbocharger, and the engine's running really well.